For today's video I'll be touching on something a little bit different than my normal usual CNC videos, but it's something I've come across recently and hopefully you'll enjoy the video and you might find it useful to you, so I thought I'd share it. So in this video I'm going to show you how to modify one of these Sunlu dry boxes for 3D printing filament, and I'm going to sort of make it and try and make it as good as this one. I'm going to explain a little bit. There are actually two different versions of these boxes. I didn't know that and when I bought these two over here, which I bought second hand, I realised that actually there was a difference. So this one in the black here is the original one that I purchased, and this is the S. I don't know if you can see on the label there, the S1 Plus. You can see just here. Oh, kind of the focus comes back. So yeah, S1 Plus in here, and the main difference between this one, this Plus, and the other ones is the fact that this one actually has a fan fitted to it to circulate the air around the box, and you can actually see that just inside here. There's two slots in the actual heater plate where the air comes through and is circulated around. The S1 standard boxes, they just rely purely on convection current, so they have no fans fitted at all. Just for information, I bought these ones second hand, and somebody's already modified these and fitted these little humidity sensors, but we'll touch on those a little bit later on in the video. So I purchased this box about a year ago. I've been really happy with the results, so I decided I needed to get at least another one, and that's where I come across these two. They were being sold online second hand. So I bought them, got them back, and realised they're a bit different, and the performance actually was nowhere near as good as this one was. So I thought, right, we need to modify it. So that's the basis of today's video. So what we're going to do is, in order to modify them, is we're just going to add. So there's this one, the S1 Plus, has the 4010 fan inside, as we've seen in those slots. So we're going to add our own 4010 fan to this unit, and we're also going to add a small wedge onto the back of the unit as well. You can actually see I've already stuck one of them on the back of there, so you can see that's what we're going to do, and we're going to modify the final box on video. But I'm also going to show you the performance later of how this works versus the standard box as well. So yeah, as I said, we're going to add that fan into the back of the box. We're going to add it in like this one, which has already been modified. You can see the fan there at the back, just underneath the heater plate. Looks almost like it was there from factory. So yeah, looks pretty good, and as I said, I've already stuck the wedge on the back of there. There's two holes in it, so I can screw it into place once I'm happy with it. At the moment it's just double-sided taped on in there. There are some other modifications online that I've seen as well, where they actually stick the fan on here and blow it straight down, which is another option that can be done. I probably would create a very similar effect. The only reason I went for this one is because I think it looks neater in here, and also it still means there's no exposed wires, and it still means I can disconnect the lid if I want to, and take the lid off if needs be to swap it around for any reason in the future. Okay, two important things then that we need to discuss before we do this modification. One is it'll void any warranty, and you do this at entirely your own risk. The second is that the fan will be on all of the time when the 24 volt is connected. So in order to switch the device off, you either have to unplug the device from either the wall socket or from the back of the box itself. So with all that said, let's get on, let's do the modification, and then we'll see later how well that performs against the standard box. Okay, so let's get down to modifying it then. So now what we're going to do first of all is just going to pop the lid off, so that we can work on the box without the lid in, and we'll just take the filament rollers out from inside as well. So let's just pop this off. There we go, we can move that out of the way, we won't need that till the end. Okay, and we can also take these filament rollers out from inside, so these just fit in, but you just a little bit of sideways pressure on the box and they come out with the bearing on either end. So again, a little bit of sideways pressure and they come out quite easily. Okay, so what we really need to do is to be able to get this heater plate out, because this is what we're going to modify down at the back here. But of course this we can't get this out until we've disconnected the wiring. The wiring's really tight in the front side of this, and if you try and take this out straight away, you likely would damage the wiring. So what we first need to do is we need to take this cap off. So we're going to turn this upside down. There's a couple of ways you can do this. I've seen a way online where they puts a little bit of tape on here, uses a set of needle nose pliers just to apply some pressure onto the tape in about those positions, and he presses down and pulls outwards and that comes away quite nicely. I didn't have much success with that method, I must admit. These are quite tight in the box and they do take a little bit of work to get them off. It's the most difficult part of the modification, to be fair, is getting this panel off. So let's go. I'm going to just use one of these little spudgers, see if we can get it in there, and we can press down. And there we go. So that panel comes off, and it's these little clips that we're trying to press down to get out on here. Hopefully you can see that on the video, those little clips. What we'll actually do is trim these back a little bit before we put it back, so if we ever have to remove it again, it comes off a little bit easier. So we're going to put that over to one side as well, and that leaves us our control board here on the front to remove. Now there's 4 screws that we need to remove to completely remove this panel, but we also need to unplug these connections. There's 4 connections to unplug here, so I'm going to just do the 2 larger ones. Again, a bit of delicacy because they are quite thin, especially the other 2, and then we're going to unscrew this front panel. Okay, that's the board off. So you will see, once you've got the board off, there is actually a fan connection on here, and I assume that's what they use in the S1 Plus board, so that this control board can control the fan. As we said earlier, the way that we're going to do it is we're going to just wire it straight to the 24 volts, so whenever the device is plugged in to the power supply, the fan will be running regardless of whether the actual heater under the screen is on. That's just something to be aware of. We can't use, unfortunately, these pins on here because it's not that easy to see, but there's some componentry missing. So Q1 here, which is the, I guess, in the MOSFET to control the fan, and there's a diode, and there's some other components missing there which are related to the fan controller, not on this particular board. So we can't use those terminals, which is a shame, but we can still connect it direct. So that's what we'll do. Okay, so now we've got the wiring disconnected, we can undo our top screws. Okay, put the box over to one side for a second, and we'll concentrate on the actual heater plate. So this is the front with the wires coming out of here, and the S1, as we said, the S1 Plus, sorry, as we said earlier, has the slots cut in here for the fan. Obviously we can't do that because in the standard box this heater elements run through that area, so that's why we're going to opt to use the back, which is the opposite side from the wires. So this part of the heater mat at the back here, we could just cut into that without any problems. As long as we don't damage this structure here, we'll have no problems at all. So what we're going to do now is we're just going to take our fan, we're going to mark it on the top here, and we're going to make 2 cuts back, and then just simply bend that down out of the way, so we don't have to do too much cutting for this modification either. We'll just go and get those 2 cuts put in. I'm just going to use a hacksaw just to simply put them in, and we'll show you that once it's done. Okay, so now you can see those two cuts that we've made there, and now all we're just going to do is bend this whole piece down out of the way so that there's a nice hole there for the fan. Once we've done, we should have room for our fan to sit against it and still be within the confines of the aluminium piece. So that's the aluminium piece. Now we can get the box back and we need to fit the fan. Now to do that, it's a little bit tricky in that the fan itself, we want it to go down here and we want it to sit just below these two posts. So the top of the fan sits just below these two posts, but as you can see it won't go down any further. So we're just going to lightly trim these two ribs inside the box down just to allow the fan to sit that a little bit further. Okay, so there you can see we've trimmed those down now, and the fan can sit all the way down in that lower position, which is where we're going to fit it. So we're just going to drill that into position. Okay, so there's the fan fitted now at the back side of the board. You can see it's just sitting ever so slightly below those two mounting posts for the heater plate. So the next thing we're going to do is we're going to just cut this wiring down now, and we're going to solder it directly onto the pad inside here. I don't know if it's that visible, but we have already a red and a black connection inside there. I'll move my hand so the focus comes back. You can see there, so we're just going to move that wire down to the bottom, cut it, solder it onto those, and that's our permanent 24 volts for the fan. Okay, so we've just moved this round a little bit. It's struggling to focus because, apologies, the light isn't the best at the moment. I'm just moving the workshop around, and yeah, it's we're not capturing the best light for this modification video, but there we go. So we've got the cable now soldered into the bottom one. Make sure that you get that the right way round, the right polarity. Okay, so now what we're going to do is just tuck this wiring out of the way. We're going to move to the other end of the board. And right down in the bottom of it, I'm trying to capture the light in the best way, but right down the bottom of there you can see right here is the temperature sensor, and what we're going to do is just take this adhesive off the top of this. We're going to move this as far, about a centimetre away from this back wall here, and that gives us a little bit more, it will give us a little bit more heat from the heater plate when we actually reassemble it. So as you can see, we've now moved that sensor all the way to the front of the box, about 1 centimetre away from the wall. Just be careful when you're moving and playing around that sensor. The wires are really thin, really delicate, but it's fairly easy to move. So all that's left now is for us to actually put this thing back together. So we need to stick our wedge on now, it's optional, you don't really need it, but I like it because I think it helps to flow the air around the box a little bit better. And we're just going to stick it about 1 centimetre up from the end of these ribs in the centre here, and eventually, I say, it's got holes in the back, so I will drill through and screw it on eventually once I'm happy with the positions, etc. And we're done. So we have our wedge on the back, we have our fan just inside here, and our thermometer or temperature sensor has just been moved a bit further that way. So now all we need to do now is power it up, give it a test, we'll see what happens. Okay, let's just spend a couple of minutes then just talking about these humidity gauges. As I said, you sometimes see these fitted on units from factory, depends on the manufacturer. This one's been retrofitted before I got a hold of the box, Sunlu themselves don't fit them, either the S1 or the S1 Plus, and you can see I haven't bothered to retrofit the S1 Plus with one either. There's a good reason for it. They're absolutely useless. They don't give you any usable information whatsoever as to the condition of your filament. So they don't tell you how wet the filament is when you put it in. They certainly don't tell you when the filament's ready for 3D printing either inside there. They're just not very good. So temperature wise, this unit's widely inaccurate. It currently says 25.3. My calibrated gauge just off camera is telling me it's 22 degrees in this room at the moment, so we're already 3 degrees in error. And as we heat up the box, because this surface is outside the box, it stays cooler, and that affects the reading inside, so it actually gets more inaccurate the hotter the box. Humidity then, or more specifically relative humidity. What does it really mean? Well, don't forget this is measuring air, not the filament. But at any given temperature, the air can hold a maximum capacity of moisture, and that's a finite number. It cannot change. The only way you can change that is to change the temperature. So that finite capacity is called 100% relative humidity, and so you can see here we're at 49% of that capacity already inside the box in here. So if we heat this air up inside the box, the capacity in the air to hold moisture goes up massively. It's exponential. So as we get hotter and hotter and hotter, the air can hold more and more and more and more moisture. So that relative humidity line goes up as well. So even though we don't change the amount of moisture that's in the air, if we heat the air up, this value will go down. I'm going to explain this, I think, a bit more on a graph, and I think it'll make a lot more sense to you. Okay, so here's our graph. Temperature across the bottom in degrees Celsius, and then on our left axis up the side we've got grams of moisture per kilogram of air. That could read millilitres per cubic metre, so same values in there. So at any given temperature, the air can handle a maximum amount of moisture, or a maximum number of millilitres per cubic metre of moisture, or grams per kilogram of air in here. And as we increase that temperature, you can see that maximum amount of grams or millilitres of moisture actually increases as well, and it's on this sort of exponential curve. And this curve is our 100% relative humidity line. Okay, so let's look at an example. I'll try and explain this even further. So let's say we have 20 degrees C, and our gauge is showing us 50% relative humidity in there. So at 20 degrees, with a percentage relative humidity, we can calculate how much moisture is in the air. So that's 7.31 grams or millilitres per cubic metre in there. If we then simply seal the box and we increase the temperature inside the box all the way up to 50 degrees C, now the air can hold nearly 95 millilitres per cubic metre, which means that our 7.31 grams or millilitres per cube now equates to 7.7% relative humidity. We actually haven't removed any moisture. We haven't dried anything. We haven't changed anything except for the temperature. Yet our gauge is now saying it's at 7.7%. So just by looking at that figure on our gauge doesn't actually tell us anything. So it doesn't tell us how much moisture has been removed from the filament. Because remember, this is an air measurement inside the box. It's not a measurement of the filament either. Yeah. What we actually would want to see, if we were to plot this properly from an actual run, would be that this green line would slightly climb and perhaps finish at something around 16%. Maybe adding an extra 3 or 4 grams of moisture into the air, because that means that it's been absorbed from other things inside the box, like the filament, the reel, etc. So we'd actually see that, relatively speaking, we would have more moisture in the air at the end of the process than we have at the beginning. These gauges that are on there, if you don't have them, I strongly suggest you don't fit them, because unless you know and you can graph all this and you know how much moisture's in the filament itself to start with, then these numbers mean absolutely nothing. What is important with these boxes is to increase our temperature as much as possible. So the more we increase our temperature, the more, let's say, room there is in the air for moisture to evaporate into. So obviously if we were to hit, let's say 35 degrees, then we can only handle 37 grams. But if we were to go all the way up to 50, well, that's nearly 3 times as much, and we've only got up another 15 degrees. So the hotter, every degree counts, and the hotter you can make the box without damaging the filament, then the better the performance will be. We just can't measure that performance. Hope that makes sense. Right, let's go do some testing. So you can see now the unmodified one is actually, this one is hitting its temperature first. It's going to reach 55 very shortly. And that's because all of the heat is being contained in this bottom section, and because the sensor is very close to the metal heater, then it thinks it's hit temperature first, but the reality is the rest of this box is cold. It's just this area that's getting hot very quickly, and because it's only heating this small area at the bottom, that's why it can hit its temperature, let's say, the quickest. On our modified one, the temperature inside the box is going to be very, very similar. But the difference now is we're using the fan to move all that air around, and we're moving the cooler air from the top into the lower sections as well, which is obviously why it's taking a little bit longer to hit temperature, and the fact that we've moved the sensor all the way forward away from the heater. Similar with the S1 Plus box, this one the sensor is still in the original position. So you can see we've hit 55 already now on the standard S1 box, but again the temperature inside this box is pretty low. You can feel the difference already. These boxes are already warmer up on the top. This one's cold still on the top, even though our temperature sensors tell us something different. So don't take too much note of what these are telling us. These are only telling us when they hit 55 degrees they'll shut the heater off. And of course this one's already started shutting its heater off, and it's still cold. So these have now been running for about 2 hours or so, and you can feel a very big difference between the standard S1. It's lukewarm. I wouldn't even say it was hot or anywhere close to hot on the top at the moment. The other two, however, they are quite hot to touch on the top. So what we'll do now is we'll use the our calibrated temperature probe, and we'll put that inside the boxes, and we'll take a measurement reading on there, and we'll start with the S1 and we'll set that as our benchmark. So let's put this in, get it onto the right place on the filament, which is just over the top of the filament, and we'll see what temperature we can get up to. Yep, stabilising around 48 degrees for the S1 Plus. So let's go and have a look at the modified standard S1. Bearing in mind that the front temperature on here says 40.1, which, as I've explained, they're wildly inaccurate, and they're taking some of this outside air temperature as well as inside air temperature. So let's put this in over the top of the filament, the same place as we've had it before. There we go, you can see the gauge. Stabilised there at 47. Okay, so now we'll just check that in the standard box. So again, we're going to put that into the same place. This box, by the way, says 35.9 on the front. So again, wildly inaccurate. But we're going to check this one anyway and see what we like just above the filament. Actually, we're coming down, look. We can just see there that we're in the right place. In exactly the same place as the other boxes. And here we're at 39 degrees. It actually came down there as I put the thermometer in, so it's going to pretty much be stabilised at 39. It may even drop one more, but we'll call it 39. So you can see quite clearly there's sort of 10 degrees difference between the modified, or 1 degree difference between these two, but there's 10 degrees difference to the unmodified. Okay, so here's the results from our testing then. So our standard S1 box got up to 39 degrees C at the top of the box, and our modified S1, as we saw, got up to 47 degrees, and our S1 Plus, which was our benchmark, was 1 degree higher than that at 48 degrees. So you see it's quite a big jump there at the top of the box between the standard and the modified. So definitely well worth doing from that point of view. What does it really mean? So as you can see, we've got this back on the relative humidity scale here, and what we've actually done by increasing this box temperature by only sort of 8 degrees from 39 up to 47 at the top of the box, what we've actually done is we've increased the amount of moisture that the air around that filament can hold by 40%. It's quite a big jump. And of course, we've actually heated the filament to a much higher temperature as well. We've taken the filament up to 47 degrees. So that filament is now much more likely to give up its moisture, and there is 40% more room in the atmosphere around that filament to absorb that moisture. So consequently, what's going to happen is the drying process is going to be much, much quicker than that. And if we look at the S1 Plus there, that's another 3% more again. So what does it really mean in reality? Okay, well, I live in the UK, and my typical printing filament is PETG. It does absorb moisture even here. It doesn't absorb huge amounts of moisture, but I do have to dry it. And what I find is in the modified S1 or the S1 Plus, after about 2 hours in the dryer, it's perfectly usable and it's fine. In a standard S1, I have to periodically rotate the filament around because the main portion of the heat is at the bottom, and I know these measurements here were at the top, but the main portion of the heat is at the bottom, so I have to periodically rotate the filaments around a little bit, and it takes 4 to 6 hours to get that filament usable. So really it's about time. All these boxes work, they all dry it, but I'm saving myself 2 to 4 hours each time with the modified one. So on that basis alone, I think it's well worth doing this modification. If you've got any comments about it, or you want to ask any questions, please feel free to do so. Put them in the comments below and I'll do my absolute best to get back to you. Thanks for watching, and I hope you found it useful. See you next time.